boom, 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 boom. You see? You need broken sticks to do the polar opposite of the tetrahedron. They have to be broken because the sticks intersect.
Could you do that again with a light off because you can't see it as well?
Okay.
Yeah, we don't need lights, period.
Well, the video does.
Video does, you can see.
Boom, boom. Can everybody see this? You need a broken stick to go in between the other sticks to generate the opposite polar structure, which is given by the code itself. Isn't that sweet? And so you take the code, and I didn't have time to do the whole animation. I didn't finish on that. I will when I get better funding. You see, if you keep doing this and you follow the code, you're going to be able to do the whole 64 tetrahedron grid. Actually, after you finish the code of 64 sticks, of 64 code, each one making a tetrahedron, you will have made the 512 grid, which is the next fractal level from 64. So if you actually follow the I Ching code, which is the trigram with 8 first, and then the 64 hexagrams, right? And you generate the 512, then you follow the exact progression. Okay, so let's see. I was playing with the 5 spiral because, you know, I was doing some interesting math. I found some very interesting, as a result of an interaction with a friend of mine, I found some interesting function to the 5 spiral that I had never seen anywhere else. Now, I might be missing something, but I found that the 5 spiral behaves in a way where it generates boundaries, condition, a very specific radius from each other if you array the spiral in an appropriate way. Okay, so I was building a 5 spiral, building it using, you know, phi relationship by segments, and at one point, when my spiral was approximately here, I just continued to add segments without changing their relationship to each other. Meaning, I continued to add segments to my spiral, but instead of increasing my segment length 1.618 every time, I just kept the same ratio. And within a few segments, I had a perfect circle coming back, right? And that circle, you know, encompasses the spiral dynamics, but interestingly, the spiral is not in the middle of the circle. And I thought that was interesting because when we plot orbitals of particles falling into a black hole, we usually plot them on a geodesic in which the center of the spiral is the center of the black hole, right? But it doesn't naturally do this if you're doing it geometrically. So I thought that was interesting. But I was playing with this and Andre looks at me and goes, hey, that's not in the middle. And I'm like, yeah, no, it doesn't fall in the middle. I'm trying to figure out what the ratio that is. And it's Marko Rodin? And he said, wait a minute, do a Marko, you know, crazy geometry trick. And I'm like, okay. With the CAD program, I was able to reproduce it. And sure enough, turns out that the spiral vortices intersect exactly where what you call your emanation point is, which is not in the middle of the sphere, neither. And when you look closely at the spiral, see, but it never intersects that point. The point actually is more precise than the spiral. The spiral is trying to get to that point, and it'll never get there. You see, when we look at the path of a particle going into a black hole, we keep doing this. We only look at one particle, like there would be only one particle falling into the black hole. But that's not the case at all. There's thousands and thousands of particles falling into the black hole. And this is only the path of one particle. So what happens if I multiply this path, let's say by 12 elements. So now we've got 12 particles falling into the black hole. If you actually multiply the spirals, right? So that you don't just have the path of one particle falling into a black hole, but you got a whole bunch of particles falling into a black hole.
Coming in randomly?
Not random.
Not random, at equidistance, or, you know, if you take, instead of taking the math of only one particle falling in, well, let's say you have 12, and they're at equidistance.
Put them at some starting point.
These boundaries here.
Right.
Yeah.
These boundaries disappear right out of the 5 spirals.
Which are more halving.
Yeah, because the spirals actually touch and then gets wider and touch again together and creates boundary conditions like rings, like fractal rings. And they interfere with each other.
Oh wow.